Hope everybody is doing well today. Homework number 4 is available now on Blackboard. And with homework 4, you're going to start to use Microsoft Excel. And I think probably if past experience holds true this semester, some students are going to be completely comfortable and already have spent enough time in Excel that they feel like they're proficient. And then there are going to be some students who really haven't used it very much, and maybe it's intimidating or even terrifying to start having to do your homework assignments in Excel. You shouldn't feel that latter of the two. You shouldn't feel terrified or overwhelmed. It's a tool that is relatively straightforward, and I'm willing to help you as much as I can. And of course, remember that since these lecture recordings are posted on YouTube, you can go back later, and if I went through some keystroke or demonstrated a feature a little too quickly that it didn't get to you the first time around, you can watch that over and over and over again. So please make use of those resources and tools because it's important that you become proficient in Excel. You'll be able to use it on at least 2 of the exams this semester, and the homework assignments that you're going to submit, you'll oftentimes be turning in both hand calculation as a PDF and then also an Excel file. So again, I'll point out the due date is Monday, and for some of our earlier assignments there was a full week for you to work on that before it was due, but in this case you don't have a full week. Today is Wednesday, you've just turned in homework 3, and the next assignment is due on Monday. The good news is that these are manageable bites. These questions so far are relatively simple questions, and so although there are 10 questions on that assignment, each one of them is pretty small and just intended to be extensions of the in-class exercise ideas. This comes from chapter 3 in the textbook, and so I hope that you're following along and kind of supporting your learning with the textbook as well as participating in the lecture, because no one source of information is adequate, and so I think it's really good that you make use of that book. All right, now in the in-class exercise that we went through on Monday, we finished by looking at this problem that calculated the unknown n. And what we did was we first looked at the crossover point in the factor table. And so by designating the present value of 60,000 and the annual recurring income of 8,000, what we did was we determined the P to A ratio, and I think if I remember correctly that was 7.5. And then what we did was we went down through this table and we looked for the crossover point to where the P to A ratio is now 7.5 or greater. And so you see that that lined up to be the year 15. And what that meant in kind of real world terms is that when you have 15 consecutive payments of 8,000, then the present value of those 15 payments is 7.6 times the amount. And so if we just multiply 7.6, I'm getting my calculator out now, hopefully you've got one handy for today, so 7.6061 times 8,000, that is $60,848. And that is greater than the original upfront fee of $60,000 to purchase the equipment. And so that represents the first point at which the investment now has profits that are greater than the original cost. And that's when we're discounting those future profits to the present. Okay, so I wanted to draw your attention back to that idea that, this idea of finding the break-even, the number of years until we get to profitability. We went through the Excel demonstration, and also there are other ways that we can determine how long it takes to break even. And so when you're working in Excel, as you will for the homework as I've just explained, feel free to verify your solution another way. You know, if you're solving a problem with Excel and you get some number that just seems absolutely outrageous, one way to check and see if maybe you've got a typo, or one common mistake would be putting the interest rate in wrong. You know, if in Excel, if you put 10 for the interest rate instead of 0.1, you'll get some pretty incredible results. But if it seems off, double check another way, like use the factor table or use the equation method and double check to see what you've got. Okay, now remember, the other kind of foible that Excel has that we're going to be dealing with this semester is the fact that it flips the inflow and the outflow. When you use the built-in functions for present value, future value, payment, we're going to manually have to put in the minus sign to ensure that when we are given, for instance, an inflow in the future, and we're simply finding the magnitude of that inflow in present terms, where we don't necessarily want it to change the sign, we'll have to manually put the minus sign in. So that's maybe the one caveat that I presented in Monday's class, that we have to be a little bit cautious, and Excel isn't giving us the prompt to do that like it gives us the prompt when we start to use the built-in functions. Okay, so that built-in function PV is something that we saw in the last class meeting, and what you remember is the first field is where it asks for you to define the interest rate. And the interest rate has to be expressed as a decimal. And so if it's 10% interest, then it would be 0.1, not the number 10. The next field, Excel will give you the hint in the prompt that that should be NPER, meaning the number of periods. And then we use this double comma to skip over the field where it's looking for a payment amount. And most typically when we're using the Excel built-in functions, we're doing it row by row, where every row represents a different year, and we're discounting some amount from that particular year to the present. And so we're not treating that amount in the row that it's in as a recurring annual series, but rather it's an individual future amount. So we reference that amount in the FV field, and we be sure to put the minus sign as well. All right. Now, here is a pretty complex cash flow diagram that would be tricky to solve by hand. You know, if you had a hand calculation for this, there would be two approaches. One, I guess I could call the brute force approach, where you're simply doing find P given F, and you're repeating it anytime there's an amount. And that's actually what we're going to do in Excel. But if you were doing it by hand, that would be tedious, because it would force you to do as many calculations as there are future amounts. So there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 separate calculations. And so that would be one approach if you were doing it by hand. Another might be that you could, for example, take this annual series and find a single present value that would actually be in year 1, because remember, our convention for find P given A is that the P, the lump sum present amount, is 1 year prior to the first annual amount. And so if you did a find P given A, then it would actually take the equivalent value of that 12,500 each year. It would find a lump sum amount in year 1, and then you'd have to take that lump sum amount in year 1 year further back to get it to times 0. And so that has a little bit more finesse. It's not quite as brute force as treating each row as an individual year. And we will do that in future class meetings, where we'll kind of try and see what are the different strategies to calculate the present value in as few steps as possible. But today we're going to go through this together in Excel. I'm going to try and take it slow so that you can follow along. I've previously suggested it might be useful if you have access to 2 screens as we do this. You know, if you have your laptop plugged into the TV and can extend the monitor so that you see this lecture on the television, then work Excel on your own computer. That's one way. Or you can just, you know, rearrange the windows. But we're going to fire up Excel. Here's the in-class exercise. that I hope that you've got printed today. So it's that same cash flow diagram that we've just been looking at. And we want to find out what's the present value. And we'll use two methods. We're going to use it implementing the PV function that's in Excel. And you'll see here that I've mentioned the column titles that there should be. There should be a column for year, amount, and PV of amount. Now this time we're not going to do that cumulative PV of amount column. We did that with the break-even problem from last time, but we won't use that in this one. All right, so I'm just going to copy this image into a spreadsheet file. You won't need to do that if you have the paper printed out and in front of you. You've got it handy enough to where you don't necessarily need to paste it, but you could. You know, you can always do like a screenshot and then paste the cash flow diagram into your spreadsheet. You can do the same thing that I just did if you like. So here is our cash flow diagram, and we're going to discount all of those future amounts to the present, where it's defining the interest rate as 7%. All right. So first, up here at the top, first things first, we will say what is our interest rate. And you need to put the label for it in a different cell as the amount. Because if I just typed in like I equals 0.07 like that, I can't refer to this location as a number. This is a string of text. And so I couldn't refer to this string of text if I was typing an equation. And so that's why I say I equals, and then I tab into the next cell, and then it's here in a cell that I just put the number 0.07. Because now this is a string, but this is a number. And a formula has to be looking at a number. So you may have wondered previously why I separated the label and the amount like that, and now you know. Okay, so below that, if you're following along, and I hope that you are with Excel on your end. By the way, you know Excel is free, right? You can get access to all of the Microsoft Office products through the university. That's one of the things that your tuition fees go towards, is subscriptions to Microsoft Word and PowerPoint and Excel. And so if you previously don't know how to get to Office 365, then there's some nice links on IT services that explains how to use that, or I'd be happy to help you get the software if you don't have it already. And they have versions that you can download and run on your own machine, and then also kind of live versions that are cloud hosted. And those are sometimes a little more clumsy than having it actually installed on your machine, but in a pinch it'll do okay. All right, so column titles: year, amount, PV of amount. It's good if you're paying attention, but it's better if you're paying attention and also doing this. You'll retain it and you'll learn it better if you are participating. So what we need to do is have a row for every year, starting with year 0. So 0, 1, and now we don't have to type them all. Remember, some of the tricks that we looked at before is that once you've begun a pattern, you can click and drag down here in the lower right-hand corner, and it will continue the pattern for as many rows as you need. And we need 16 years, like that. Okay, so next step, and this is one where I see students make mistakes sometimes because it's just easy to type in the wrong number, is you have to translate this diagram into a table. And so you manually key in the amounts. Now there's no amount that's already known and given at time 0. This unknown we are going to be calculating, but there isn't already a given amount at time 0. So I'm just going to put 0 for that, 0 for 1, 12,500, and then I can repeat that amount 4 times. And then year 6 and 7 is nothing. Year 8, 15,000, and that repeats 4 times. And then year 12 has nothing. Year 13 is 17,000. Year 14 is negative 7,000. 0 in year 15, and now 8,000. In the cash flow diagram, it was referring to A here because it was an annual uniform series. And this was also an annual uniform series. I don't have to do anything special when I'm putting it into a cash flow table. I don't need to like differentiate between an A and then these were F, meaning a single future amount. I don't treat them any differently in the amount column. They're just amounts as far as Excel knows. And it may be that they're the same amount every year, but frankly Excel doesn't care one way or the other. It's just an amount in a certain year, and it's going to do the calculations based on the amount, the year, and the interest rate. And the labels that appear on the diagram don't affect that. All right. Now, I'm going to pause for a moment, and if you're following along with Excel, and I hope you are, try to remember how to use the PV function. So what we want to do is we want to find out, for instance, the 12,500 that's in year 2, what is the present value of just that amount? And so you're going to use the PV function to discount 12,500 2 years back in time to get it to year 0. And so that'll be some amount. And then the amount in year 3, discount that 3 years to get to time 0. And that's going to be a lower present value because it will have discounted another 7%. It's discounting more years to get it to 0. So you start off an equation by typing equals PV parentheses, and then it's going to start to give you those hints of what it wants to see. So I'm going to pause for a second and see if you can get the PV of amounts for all of the years. Then I'll resume and show you what I've got. And of course, we're going to want to know the total down at the bottom to find the cumulative amount at the present. All right. So I'll give you a couple of minutes to set up that equation and apply it down through the entire cash flow table. Zoom the recording here. Let's take a look at our method. And so when we start equals PV rate. Now, I hope that you'll remember that when you click on a reference to the interest rate, you need to anchor the reference to that cell. And if you press the F4 button on your keyboard, it'll automatically put those dollar signs in. And then that allows you to move on to the next part of the formula. So now NPER, number of periods. And for this, if we're finding the present value, it's just the year that you're in. So whatever amount is in year 0 has to move 0 years to get to the present. And then when we drag the formula down to the next row, it's going to be looking at this number, 1, which means any amount that is being discounted is being discounted 1 year. And so with each successive row going down further, it's going to know how many years to discount that amount to get it to the present. All right, double comma, because we don't want to tell it that this amount is a payment. We want it to know that this amount is a single future value. So for instance, that $17,000 in year 3, that's just a single future value. And we don't want it to think that there are 13 payments of $17,000. There's only one payment of $17,000. It's a future amount. And so like when we're in row 11, it's going to be seeing that there's $15,000 in year 11. And we don't want it to think that there's 11 payments of $15,000. We want it to just know that there's a single amount of $15,000, and we want to find the present value of that $15,000. All right, so we skip over the payment field with the double comma, and then equals minus of the amount. Okay, so we want it to say minus of the amount, and it's going to return the 0 because there was 0 amount, and we can drag that formula down through all of the times. Oh, there's those brackets that drive me so crazy. So I'll change the formatting there to currency, and now it's a minus sign rather than being in red. Okay, so did anybody else get these same amounts when you were putting the functions in? Does that look familiar on your end if you're able to follow along and are also doing the calculations? So a yes from Aaron, a yes from Tyler, good. Chad, Zach, Braden, 7 more yeses, good. Excellent. My computer's blowing up. I love this. I'm going viral. All right, so now what we need on to do is find the total. So you can type here total, and that's just a label. That's not a formula. So we just type in total so that we know what the amount is. But then next to that is where we're going to find the formula by adding up all of these amounts. Now, I'll show you a quick tool that's kind of helpful. Is if you just highlight the amounts, then look down here. It's real small, but you can see where it has the sum at the bottom. So anytime you highlight amounts, it'll tell you the average, tell you how many you have highlighted, and the sum. So if I highlight all of those, the sum of the present value, 260 and 55 cents. So that's cool, but it's good to actually have the formula in case you print it. You can't just highlight the cells, and it wouldn't print out the sum that way. So we'll do equals sum and highlight the amounts like so. And we could close parentheses, or sometimes when I'm real lazy, I don't even bother because Excel knows it should close the parentheses. So I'll just put enter, and then it finds the total there. Can you just type the row and column numbers if you were, let's see, let me read the rest of this message. If you have a huge list, let's see. Yeah, so yeah, you don't have to necessarily scroll down. If you look at what it did is I could type those values in as well, C4 through C20. So the sum of C4 through C20. So the little colon is how Excel knows that it is, that means through. So to answer your question, Ronnie, yeah, you can key those in rather than clicking and dragging. And if you had hundreds and hundreds of pages, then that could take a while to scroll through all of them. All right, now, when you submit homework on Blackboard, the grader has 40-something assignments that they're grading. It's a thankless job. I feel grateful to our graders that they're willing to do it, but boy, I sure struggle when I have to grade 40 assignments in a row. And so let's be kind and understanding to the grader and try and make it as easy as possible for the grader to find your answer. And so some ways to do that. If it's asking, let's see, what did the question ask? Solve for the present value. So what you could do is you could say, highlight it. That's one way to make it obvious that this is the answer. So highlight it in yellow. Maybe I'll make it in bold. And I'll put a little note next to the side of it. Answer. The present value of the cash flow diagram is shown here. Yes, thank you to the grader. All right, so the point is, engineering communication isn't just about writing reports, and it's not just about giving a speech to clients. Effective engineering communication is also making your spreadsheets easy to follow and clearly identifying what is the answer that somebody needs to pay attention to. So it's not the grader's job to go into your spreadsheet and look for the answer. It's your job to communicate the answer to the question through the spreadsheet. So we've just done that with this first method here, the PV function. Before we go any further, are there any questions Brett says mine has number signs instead of numbers. I bet I know what that is. If your column isn't wide enough, then it'll do that. So if you're seeing those number signs, it simply means up here at the top, make your column a little bit wider, and then it'll change from those number signs. And one way to do it is if you see here between C and D, you can drag it so it's wider, or if you just double click, it'll make it exactly as wide as it needs to be to fit everything. So see how I just double clicked and then it made it wide enough so that that label fits into the width of the cell and all of the numbers are shown. So Brett, does that reveal the numbers now instead of the hashtags? Good. And I bet you probably weren't the only one who had that issue. Thank you for bringing it up. Does anybody have other questions? I wish we were in the same classroom together. It's so aggravating to try and teach software when I can't come and look at your screen. You know, my standard thing that I like to do in a face-to-face semester is kind of circulate around the classroom and hover behind students and look at what they're doing. You can walk up to my office. Sounds like Travis is here in the engineering building. All right. So, so that's the present value. So in other words, let's think in real world terms. What does this mean? What's its physical significance? That means you can either get a lump sum payment of $78,260.55 now, or it's economically equivalent to get this payout over time. You know, payout, including in one of the years for whatever reason you owe $7,000. Dirhams. AED is United Arab Emirates dirhams, so these aren't dollars. So that's the real world significance of this. Is what we've done is we found out the lump sum amount when you're discounting at 7% that is equivalent to that future over time. All right, so the second bullet point in this example asks us to use the NPV function. Let me show you that. You're gonna, when you see it, you're gonna say, well, why didn't we just do that in the first place? Because it's so simple. But the reason why is you need to know how the NPV function works, and also it does so much in a hidden way. It's doing it in the background to where sometimes you don't have all of the details that you may like to see. But with that said, okay, so I'm just going to write here NPV as a label. So that's not the function yet. That's just kind of a text string that will help me to understand what is the amount that's next to it, in the same way that this total was just kind of like a description of the cell that's to the right. Okay, so NPV is both a label, but then here I'm going to actually do the function. Equals NPV. Now it gives us the description. Returns the net present value of an investment based on a discount rate and a series of future payments, negative values, and income, positive values. Okay? There's one really important trick to this function, and that is the amounts you put into the function should be future payments. You should never put any amount into that function that's already at time 0. That's very important. Okay? So, let's begin with the parentheses, and it gives us the hint. First of all, it wants to know the rate. The rate is 7%. So you could type in 0.07, or you can click in the cell where you have 0.07. And you may out of habit press F4 to anchor the reference, but in this case you don't necessarily have to anchor the reference because we're not going to be dragging this formula downwards. We're just going to be applying it one time. So do or don't, it doesn't matter. Now next, value, 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 value. It just wants to know amounts. And you put in the amount as it appears on the cash flow diagram. You don't put the present value of the amount, you just put the amount. Okay, do you see that I have selected some amounts in my formula? I skipped an amount. Do you see how I didn't put in the 0 that's at time 0? That wasn't a mistake. That was intentional. Because NPV, you should only put amounts that are in the future. And so if I had put this times 0 in there, it would throw everything else off. Because what it's doing right now is it's not only looking at the amount, but it's looking at the order that we feed it the information. And so whatever it sees in the first amount, it knows that corresponds to year 1. And then it knows that this next amount should correspond to year 2. So that if I had accidentally clicked above it, it would think that this is year 1, year 2, and year 3. So this is a pretty common mistake. I get a lot of points back on exams from students who accidentally include present amounts in the NPV function. So don't do that. Keep your points. Don't give them to me by making that mistake. So what I do is I close the function, and if there's an amount at the present, then you add it outside of the NPV function. So in our case, adding 0 onto the end isn't going to change the result. But it would have changed the result, and I'll prove it in just a second. If I had included that times 0 amount in the NPV function, we'd get the wrong answer. But as it stands, as I've written it here, I think we'll get the right answer. So enter 78,260 and 55 cents. So that's pretty slick, right? It just kind of does everything else in the background that we had made this table. But let me show you if I'd done it the wrong way. Donnie, don't do it this way. So NPV rate 0.07, and what if I accidentally included that amount, the times 0 amount? Then I get the wrong answer, 73,000. So write a note to yourself that when you use the NPV function, only include future amounts. And then whatever amount there is at the present already doesn't need to be converted. Oops. So you'd add it outside of the function. Okay, so let me write that note to myself here. This is the present value of the cash flow calculated using the NPV function. Note to self. Never put present amounts into the NPV function. If it's already at the present, it doesn't need to be converted. Okay. Any questions on this first one? We're making good progress. Now, for the cash flow diagram below, solve for the future value. 8.5%. There's the FV function, which we haven't used before, but we're going to do it today. And slightly different columns. Let me show you why we have slightly different columns. So first thing, I'm going to copy that diagram so that I can paste it over and have available as a visual reference. Here is a request. Don't do the next problem below the first one. That will be messy for a couple of different reasons. So instead of putting it below the first problem, just create a new tab. So you have one problem on one sheet. So this was, question 1. This will be question 2. So it's just a separate worksheet, and I'll paste my diagram into that. And the first thing we do is define the interest rate. So 0.085, 8.5%. And then the column titles, it instructs us to add is year, years until year 16, amount, and FV. Year, time or year. What did I say to put it as? Year. Okay, I'll call it year. Year. Now, years until year 16. What's year 16? That is the year that I'm trying to find the equivalent future value in. So if you're doing a different problem and it says to find the amount in year 8, then you wouldn't do years until year 16. You do years until whatever is the time that unknown future amount is. Okay, so in this case, we want to find out the future in 16. Amount FV of amount. So we've got a new time column. This is kind of like a quasi time column, a secondary time axis maybe. Okay, so we go 0 through 16. All right, so 0 through 16. Now, we need to start, how many years is it to year 16? Here it's 0. This 10,000, how many years into the future are we compounding it? We're compounding it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 years into the future. So the reason why we want to have this secondary time column is when we do the FV function, we want to have the number 16 available for the calculation when it's compounding n equals 16 years. Okay, so 16 and then 15 and then 14. Excel can detect that trend, I think. So we don't have to manually type it in. You could just fill it that way. Or you could do a formula. Equals 16 minus that year. And you'll get the same thing if you type it in as a formula. All right. Now the amounts. 10,000, 0, negative 11,500. And we have 4 of those. And then a 0 at year 6, 15,000. 3 of those. And then a 0, 17,000. A gap year, negative 7,000. Oh, so easy to type the wrong thing. Got to double check. Nothing and nothing. There's nothing at year 16 yet. So this is our cash flow table. Okay, now I'm going to pause for a second and see if you can figure out the FV function. So you start it off the same way that you start the PV function, equals FV parentheses. But I want to see if you can find the total future value at year 16. I'll pause, give you a couple minutes, and then we'll rejoin and go through the solution together. Christian, what number did you get? 69,000? That's not what I got. Let's see what we can get here. Figured out. Christian, I think that's correct. 3,800. Good. Okay, so first things first. FV. So equals FV of, all right, rate. Click on the amount there, and we do have to anchor it. If we fail to anchor it, then when we drag the formula down, it's going to be looking in the wrong spot for the interest rate. So F4 to put in those dollar signs. NPER. So don't do the year, use years until year 16. And think about why. This single amount of 10,000, we have to take it 16 years into the future to find out how much it contributes to this lump sum. It doesn't move 0 years to the future. It moves 16 years to the future. So 16 is number of periods. Okay, so double comma, because we're skipping over the payment field. There's not 16,000. There's not 16 payments of 10,000. There's just one. So we use the double comma and then minus of that. Okay, so that 16,000. The 10,000, if you compound it 16 years into the future, has a future equivalent of 36,887. And now I think we can just click and drag or double click. Okay, you know I don't like the formatting there, so currency, there they go. No more red. Okay, so here's the individual amounts. And let's just look at year 13 versus year 14. It's the same 7,000, but does it make sense that this 7,000 would be a bigger amount than that 7,000? Yeah, because this is moving 3 years into the future, so it has an extra year of compounding compared to this one. This one's only moving 2 years into the future, so it has less compounding. Okay, so now I'm going to do that. Total equals sum, and click the entire range. 3,820. So we'll get in the good habit of making our answer easy to find. So it's bold, it's highlighted in yellow. Maybe I'll put a border around it. Maybe like a couple of little emojis, a label. Here is the answer. The present, future value of the cash flow is as calculated. All right, we did it. Any questions or problems that have popped up? Mine has all the right numbers, but the sign is flipped for all of them. It could be this. Remember, we have to put the minus sign in the before the PV field, because if we don't, then it automatically is going to flip. You know, it's going to take the 10,000 in revenue and think it's supposed to mean 10,000 in cost. So you got to put that minus sign there. And then anytime you make a change to 1, like, you have to drag it back down again to have it apply. You know, so for example, if I had initially done it wrong, then I can change one of them, and that doesn't change everything. I have to, once I've made the adjustment, drag it back down through another time. Okay, well, it's 12:48. Wow, I'm such a generous fellow. I'm going to let you go 2 minutes early today. I'll give you 2 extra minutes that you can start working on homework number 4. So that's due on Monday the 15th. And get an early start. Hopefully today's in-class exercise will get you going on that. We'll do some more during our class meeting on Friday. That's all, everybody. Hope you have a good one. Bye-bye.